Hey everybody, Adam with FANUC here. Today we're going to cover a really fun topic that has been heavily requested in the comments section. So first of all, thank you to everyone for comments and suggestions and reaching out because today we're going to teach you how to do fun stuff with a robot like the Moonwalk. If you guys have ever seen this online or ever wanted to do it, that is what we're going to be talking about today, and that is going to be seventh axis robot programming. So at the end of the video, I'll show you the code that I put together to make the robot do that. But we're going to talk about seventh axis control on your robot and what that is and what it means and what it looks like. So the first thing we need to talk about is it's the less fun stuff to talk about, but it's got to be aired here, is the design of how you get a seventh axis onto this robot. So in this demo, I'm going to be putting an R2000 on a linear rail, so that's pretty common. Please work with FANUC. Work with your rail providers. You know, we partner a lot with Google rail systems. We can help you specify what motor you're going to put on here. Visually, it's not here in RoboGuide. This is the virtual land of make-believe and awesomeness. But you will have a black motor with a red cap, a FANUC motor that's attached to a gearbox that's attached to a rack and pinion. In order to spec the right motor, the right gear ratio, the right sizing, the right speeds, the right cables, all that, you need to be working with FANUC. So this video is going to start based on the assumption that you've gotten that far and you just need to program the darn thing. One other thing that I'm going to show you a little bit is what it looks like to set them up. So let me first pop open a controlled start on my teach pendant. I'm going to do that by saying function, cycle power, options, controlled start. That'll work on your robot as well, controlled start. And this thing's going to boot up into a slightly different interface. Here you go. So you may or may not have seen this before if you've ever been in a controlled start situation. I'll take control here. I'll pop open my menu. And when you are setting up your auxiliary axis, your aux axes, it's going to happen down here in this maintenance setup. Now, I'm going to fly through this in 2 minutes or less. Feel free to skip ahead because a lot of times when you do this, you're going to receive the robot from FANUC with this already done. But I want it just out there, cards on the table, so you guys understand. Okay, this setup, I am going to put this as a general positioner in group 2. I'm going to talk to you a little bit more about groups 1 and 2 in a little bit, but I am going to have this set up as a totally independent servo, which has nothing to do with the robot other than you program it from the teach pendant, but has nothing to do with the robot. So I say, all right, I've got a general positioner, manual setup. Now I've already added the axis, which is why on the previous screen it said general positioner. So I don't need to add it. But if I go to line item 1 where I want to display or modify an axis, and it says which one do I want to display or modify, I want to show you number 1. So for this system, I totally just threw a bunch of bologna and cheese numbers at this. Please do not take this as anything important other than I did it. But I did pick an Alpha, the Alpha 8 4000 series with an 80 amp channel amplifier in my servo controls. Let's go to the next page here. It'll ask you a couple things. I said, yeah, gear ratio of 500 to 1 sounds great. You guys, I pulled that out of where the sun doesn't shine. So don't take it for anything glorious, but I picked a gear ratio and I said, how fast do I want this rail to move? 3 meters per second sounds terrifyingly fast, so I chose that. And then I also got to set my limits for the rail as far as lower limit and upper limit in position. Some people set the limits as zeros in the middle, and you could go, negative 1500 and plus 1500 to get your 3000 stroke. Hey, do whatever floats your boat. I want the robot to be at 0 when it's at home, and I want it to max out over at 3000. So I did that. I wanted to master my rail at the 0 position. Sure, these numbers are also rectal reach numbers. The load ratio is a number between 1 and 5. Typically, we start at a number 3, and then you can tune it as you go. So that's just kind of another guess and check, get it dialed in. But I just wanted to make you guys aware that this setup exists. Typically, FANUC will do it for you, but if you have to get into it, there it is. So let me get out of here, exit this. You know it exists. To get back into a normal cold start, we just say function cold. So, we're 6 minutes into this video, and the only thing you've learned is please work with FANUC to get your motor and settings dialed in. And then once this is on your floor and set up, now you can start programming. Okay, when you purchased your robot and you knew that you were going to be doing 7th axis stuff, you will have had to have purchased one of two things. You ought to have either purchased extended axis control, J518, or you purchased multi-group motion, J601. Very rarely, almost never, unless you're doing wildly cool stuff, rarely would you have both. I put both in here just so you can see that they're there, but typically you're picking one or the other, and I bet you 90% of the people out there are doing this one, multi-group motion. Most of the time that's it. So this video is going to focus on multi-group, but let's talk about what these mean. Have you ever mastered a robot before? I bet you have. If you've mastered a robot, you've been down in the DMR group. And I'm going to take you there just because it shows visually what I'm going to tell you. So typically when you go to a DMR group, you would see one option, DMR group 1. I've got 2 options because I've added a second group. But I want to talk to you first about this extended versus multi-group. Have you ever noticed that when you're going to do your master counts, there's a total of 9 places you can put your master counts? My robot's zeros because it's a make-believe robot. But typically if you have a 6-axis robot, you'll have 6 digits in here for your mastering. And you're like, hey, Adam, why do I have 7, 8, and 9? This is because a robot can support up to 9 servos as part of group 1. When we talk about groups, we're talking about a group, a team of servos that work together in one kinematic solution to get to a place. So if you look at this 6-axis robot, when I start moving it, you'll see a lot of servos all working together harmoniously to make a linear move, right? You can see the J2, working. You can see J3 working. J5 is working, just to keep a straight line, right? That's because I have 6 axes in one group that are all married. When you choose extended axes on your robot, you're giving the robot a 7th link or an 8th link or a 9th link that makes it all harmonious. So if I were to have made this rail be a 7th axis of the robot, then every time I move the robot or teach a point, this axis is 1 with the robot. Okay? Sometimes that's good if you're making really complex moves and you need to move the robot forward along the rail at the same time you're reaching around something. Again, it's some bonkers stuff. It's rare, but it's nice. The other thing that we talk about is the groups, right? So group 1 is anything attached to the robot. Group 2, 3, 4, and all the way up to group 8 are different groups. So I could have this robot on a 2-axis, like an Etch-a-Sketch, an X, Y servo rail, and the X and the Y could be one group, but they'd be in, say, group 2. Hope I'm not losing you guys. A lot of talking, very little programming. I'll leave in the comments where to skip ahead to programming when we go and edit. The other cool thing that I want to say, just as a sidebar, if you're still with me here, guys, is I can have up to 9 axes in a group, and I can have up to 8 groups on a robot. So realistically, feasibly, one robot could control 72 axes. It's pretty bonkers. If you've ever done anything near that, please message me, upload a video. I need to see it. So with multi-group motion, this axis, which is how I have it set up, axis 2, works completely independent of the robot. So let's get to programming. Where are we? We're 11 minutes. I will put a link here. Okay, 11 minutes in. Let's program stuff. Let's create a new program like we normally would. We'll name it Fun. And when I go to the details, you'll notice normally there's a button that shows up immediately that says Edit, and it lets you just jump into the code. With this one, it doesn't let you dive in. It needs some information first. It needs to know what groups are going to be relevant to this program. Remember, with our group masking, if you have a number 1, the group is active. If you have an asterisk, the group is inactive. So let's for this program, go over here and let's deactivate group 2, which for me, group 2 is the rail. So I'm turning it off. And I'm saying that this program will only be group 1, which is the robot. Okay, so now I can do all kinds of fun stuff, right? Okay, I'm teach a position. There we go. Okay, taught a position. And then I can say, go down here, touch my machine, whatever, and then maybe just go back. Let's just touch a machine and go back. Make that a 1. 1, 2, 1. When I go and look at my positions, it looks very normal, right? Where's X, Y, Z, y'all patrol. Everything looks normal. And if I were to run this, everything is going to look normal. Yay, touched a robot. Or excuse me, robot touched a machine. Slowly. Okay, speed that back up. Now that we have a, hey, I can touch the machine project, let's make a new program. Create. Let's call this one Machine 2 or Mach 2, something like that. Now I'm going to turn off group 1. So this program will not run the 6 servos that comprise group 1, which is the robot. It's only going to look at group 2 being active. So now let's have some fun with this. If I were to teach a point and I say, let's move linear to this point, sure, 2000, why not? Let's move linear to this point. Let's highlight it and look at it. Look what we have, guys. My robot is at the 0 position on the rail, so I literally have taught a position that says group 2, and it's got my user frame and user tool data, which don't matter, but group 2, position 0. Okay, well, I actually want to be at machine number 2. Look up here where I have G1 joint. If I toggle my group key, I can go to group 2 joint, and I can start moving this robot. Just like I normally would with anything else, just shift and jog. So now I've moved this robot, group 2, I've advanced it along the rail. Let's go ahead and touch up this point and let's just see where we're at. Position's been touched up. Let's go look at that. I am now at 1339 millimeters along the rail. And what's important to know about this is this program could give a rip less about where my robot is in space. So if I move my robot and I do something wonky like this, and I, take, let me go back to G2, and I take my robot and I run this program, even though the robot was facing forward when I taught this position, if I run this program, robot doesn't care. It just scooches right along to where it was. Let's do another one. Select, let's go ahead and let's create machine 3. Detail. Don't really care about the robot. I only care about this. End. Let's go ahead and teach a point. You'll see where we're going with this in a second. So the first time I moved basically 1,340 millimeters. So if we double that, let's make it 2680. Let's see where that puts us. Perfect. So now we have a program that takes us to machine 2 and machine 3. And we have a program called Fun, which just goes and touches a machine. What if we did something along these lines where we said, touch a machine, call machine 2. Then let's take this a little farther. Copy, select, copy, paste, and call machine 3. So let's go ahead and run this robot back to a home position. I'm actually going to use my Moonwalk in step mode just to get it home, because I know that's where my home position was. Okay, function, abort, pop open Fun. Here we go. I want it to touch machine 1, call machine 2, touch. You know what? There should be one more touch at the end, shouldn't there? Because I want to touch machine 3. Copy, select, highlight, paste, position ID. Okay. Let's see what this program looks like. It might not be 100% perfect, but let's watch it run and see what it does. Function abort and run. Robot touches, moves forward, touches, moves forward, touches. See that, guys? So what I'm doing here is I'm showing you how these positions in a program set up for only group 1 run completely independent of the programs for the rail, and everything's independent and it just bounces back and forth. This is very common of how people do machine tending and such with multi-group motion. So let me send this thing back. Let me just do a G2. I'll run it negative back to my 0 position. Perfect. All right, we're back at 0. Reset. All right, now I want to take this to kind of a next level. Let's do a next level stuff. Create, Fun 2, detail. Let's leave both of these group masks turned on. Okay, so I'm going to leave the robot group is active and the rail group is active for this program called Fun 2. So now when I go ahead and teach a position like this, and I look at my position, I see group 1, where is the robot? But look down here. Group 2 shows me where it is on the rail. So with both of these active at the same time, we can start doing some pretty cool stuff. I'm in group 2 joint, so if I move this thing forward and I take this guy, whatever, move it over, why not? So I've moved that over. Let's teach another point. And let's go look at the data in here. Position. Now I can see that I've updated my group 1 XYZ yaw pitch roll. And if I want to look at group 2, enter, I can see that now I'm at 950 on the rail. So as we run this program, if I run it, it'll be smoother if I run it with this button. Now you'll see that I'm synchronizing motion, right? You can see that as I run, it's moving forward and backward along the rail as the robot is changing position. It's almost behaving like the extended axis would do. The difference is with extended axes, you can never not break them apart. They're always married. Whereas with multi-group, hey, I can do it together, I can do it separate, I can do whatever I want. Okay. I also want to show you real quick what it looks like in the data screen. So if we were to teach a thing right here, this is a position in space, shift record. Look in here, we're going to have a similar party. It's showing me PR2, group 1, configuration, everything we're used to, but I can also look at group 2 and see where it is. So I can start modifying items one at a time in my PRs. That is my segue to get you into how I make a moonwalk. And I think the moonwalk would be a good way to show you guys how you can modify this data and have some fun. So let me split my screen here. So here's how I make a moonwalk, and I highly recommend you do it. If you buy a robot with 7th axis and you don't do a moonwalk on company time, you've missed an opportunity. So don't get fired, but please have fun. So I taught a start position, all right, PR1. And if we look at my start position, it's got the robot in a normal position, XYZ, and for group 2, it puts me at the 0 position. Nothing fancy. You know, if I say move to, it'll take me back. Actually, it'd be faster if I just go ahead and step mode and move it back there. Okay, so there's my home position, what I'm calling fun. And I call it fun, not home, because I know I'm going to do a ton of math with it. Look what I do first. I want to initialize some data. Have you guys seen before in my videos, hopefully you have, where I take a register and then you go to this 8th item, ... with parentheses, and you use the PRIJ. When using PRIJ, it's position register. The I is what register number, and the J is what element. So if I were to plunk one of those in, look what the robot's doing. I'll put this more in the middle of your screen. Look what the robot's doing. It's yelling at me, hey, you have an invalid motion group. Well, it's because I haven't picked one. So I'm going to say group mask. Right here, it's saying group 1 and 2. 1 comma 2 means 1 and 2. I don't want to do 1 and 2. I just want to initialize one or the other. So if I click on 2, you know, I can turn 2 on and off, or I can turn 1 on and off to say what group I want to deal with. So let's say I want to do group 1, position register number 1, which is fun, and then element XYZ is 1, 2, 3. So group 1 is the robot, position register 1, element 1, that's the X element of the robot of group 1. And so what I did is I'm putting it at a 1400, which is this, fore and aft in X, right? So 1400 puts it right there. All right, don't need that line of code anymore. So I'll just make it go bye-bye, delete. Yep. So what I did is I took group 1, axis 1, and put it at 1400. Then I took group 2, which is my rail, position register 1, axis 1, because I only have one axis, and I set it to 0. So that homes the robot. Well then, look what I do. I made a little counter. I'm going to do it 6 times. And the first thing I want to do is take my X of the robot and move it forward 500 and then go there. Then I want to move my rail 500 forward while decrementing my X negative 500. That's that scoochy little moonwalk that you're going to see because the tool is going backwards 500 millimeters, while the rail is simultaneously going forward 500 millimeters. So I do that math, and then I just say go there. And that's the end of the program. And I just do that 6 times. So let's go ahead and run the moonwalk again and see how this thing goes. X forward, rail forward, X forward, rail forward. And you get this little clicky, draggy thing. It almost looks like an inchworm or something, right? Dragging itself along. So again, and if you look at my moonwalk program, if we go select moonwalk and we look at the details, obviously I have both my masks active so that I can synchronize the motion of that. So guys, this is scratching the surface. I really hope it helps point you in the right direction, get you started. Please make sure when you're doing this, you're looking at group masks. You're looking at positions. You know, use your group key when you're jogging between group 1, group 2. That's the quick overall summary. If you have questions or you need a deeper dive, put it in the comments. Like, subscribe. It helps. All that fun stuff. And as always, have fun coding.